Right, David Chisnall, everyone.
Great. Hi. So I have 10 minutes to talk about everything we've done in the last 2 years. So I might have to approach Robert Watson's speed of talking. So how many people here before the last 3 talks that mentioned CHERIoT had heard of CHERIoT? Okay, so great, most of you. How many people have actually tried using the platform? Okay, so that's actually really nice to hear. So I can very quickly go through the overview, because for most of you it's revision. We initially announced CHERIoT at the end of 2022 at the CHERITech event in London. And what we were trying to do was really 2 things: to scale down CHERI to the very smallest possible cores, because all of the prior work had been on large application processors. We wanted to see if we can get the same benefits on things where, in the IBEX core that we're using, an MMU is about twice the size of the core. So adding an MMU is just ridiculous overhead. But adding CHERI support adds just a few % overhead. But we also wanted to look at an application domain where rewriting operating systems is actually feasible for a small team, and so we could showcase the things that are possible if you can assume CHERI from the ground up, if you're able to co-design the hardware and the software all the way up the stack without having to worry about, well, Linux does this way and it'll be 20 person years to rewrite that bit of Linux. We open sourced this as a complete ISA specification, reference implementation of that ISA, all of the software that runs on top, and it's now maintained by SCI Semiconductor and a couple of startups from the US West Coast that you might not have heard of. We had the last cohort of the Digital Catapult Technology Access Program finishing last week. We had 6 groups all building exciting prototypes on top of CHERIoT. They all actually built stuff that worked, which, when the first time people are really using your platform to build stuff and they don't come back saying, it's all broken, what's wrong with you? Why did you put this in your API? And most of them are actually happy. So that was very nice to see. I think the main thing from the last year is we've stabilized our 1.0 ISA. So this is something that we're now committed to supporting long term, both in the software stack and in the hardware. The sale model of this, so the formal model that defines what it does, is stable. We still have a few typesetting issues building the document, so we haven't released the specification. But there will be no changes between what's currently in the repository in terms of semantics going forwards, and the CHERIoT IBEX that Gavin was talking about earlier implements that V1 ISA. There are some interesting new features in V1. A lot of it was just cleanups, but this was something I'd been putting off till after V2 because I thought we'd need some new branch instructions. But Murley at Google came up with an approach that let us introduce separate forward edge and backward edge sentries so we can differentiate between a function pointer and a return address, which is actually all that the control flow guard that Windows shipped that came with about a 7% performance overhead did. For us, it's free, so that's nice. This builds on top of our existing rich sentry support. We use sentries to enable and disable interrupt. So when you call an interrupt disabled function, it runs with interrupts disabled. When you return, the interrupt status is restored to the previous value. So we get a nice structured programming discipline for interrupt enablement. And that means we can build higher level security guarantees, like saying this compartment can call this function, which runs with interrupts disabled, and we can independently audit that function and say, well, that only has 3 instructions in. We're pretty confident that won't break our hard real-time guarantees. But that compartment can't arbitrarily enable and disable interrupts. So, after you've done a V1, the next thing that people ask is, so what happens after the number 1? And many of us who work in computer science only know 2 numbers. And apparently there is a number after 1. So we started with CHERI ISA V8 as our starting point, and that led into the first published version of CHERIoT, which was this very exciting Microsoft technical report number, which then led into our 0.5, which I think is what we hit for Sonata 0.2, and then into our 1.0 release. And at the same time, the University of Cambridge team advanced to ISA V9, and this then led into the RISC-V draft specification, which Simon and Alex were leading, and Tariq was just talking about the amazing work they've done to try and turn it into something that there's broad consensus it's a good idea. Our goal for V2 is to not change any of the functionality, but to rebase ourselves on top of that RV32CH, which I guess for us will be CHE, and now we just need to find a way of putting RI on the end, and then we'll have the correct extension name. So this is going to be source compatible, 100% source compatible for C code with CHERIoT V1. We should be able to get assembly compatibility with some macro shims, but it won't be binary compatible, and that doesn't really matter for our use cases because you recompile your code for the new microcontroller. I just wanted to also highlight a few of the things we've improved in software recently. So one of the nice things about CHERI is it actually tells you in the hardware when stuff goes wrong. And then the immediate follow-on question is, so what should software do when stuff goes wrong? So we've introduced some lightweight exception-like structures. So if you take a CHERI fault or in fact a division by zero or a bunch of other synchronous exceptions in this during block, we can run code in the handler block, and at the end of that, both paths unify just like a normal try-catch block. We've rewritten a bunch of our RTOS code, including the automatic restart in our TCP/IP stack. To use this, it reduced the amount of code we'd written, and it also just made it much simpler to read. We've also added language level support for my absolute favorite bit of CHERI, which is the sealing mechanism, which is the thing that we use for doing type safety across compartment boundaries. So now you can hand out a pointer that has this sealed capability qualifier, and you can track all the way through your source code what you think the underlying type is. And when you get it back, you can unseal it in the compartment that is allowed to unseal it, and then you can do something with the unsealed value as just a normal pointer of that type without that qualifier. And if there has been any tampering with it, or if it's not actually a value of that type, if someone's done a reinterpret cast from an unrelated type and given you that value, then this unseal just returns a null pointer and you hit the invalid case. So this, again, gives you a nice programming model, and that's really where a lot of our work has been focused, not just on, I don't know why I'm in the hardware track talking about this, but we have an ISA, but the ISA is there to run software, and the software is only useful if it comes with a nice programming model that is easy for people to use and to take advantage of the differentiating features. And we've also open sourced the auditing tool that lets you write policies and write queries in a language called Rego from the Open Policy Foundation, which is sort of a cross between JavaScript and Python and Prolog in exactly as good a way as you'd expect that to come out. But it lets you really write rich policies that let you say things like, only the example compartment is allowed to make TCP connections, and it can only connect to this remote host. So the last thing I wanted to mention is we have now finished this book. Several of the technical reviewers are in the audience. It'll be available to purchase as soon as the copy editor stops saying, no, I just want to read it one more time to make sure I've caught everything. And the live drafts, including the drafts leading up to the second edition, will be free online. Hayden's already talked about upcoming chips, so I don't have to mention that. And I have 15 seconds to just say, if you have any questions, flag me down later, but also join our public chat, which has people in time zones from Vancouver to New Zealand So we'll answer them any day of the night, any hour of the day.